of drive mechanism for Mars missions. So let's start with Mars. As you may know, Mars is the most similar planet to Earth that we have found. We already know that it contains water, that we can extract oxygen from the CO2 atmosphere. It's not too hot or too cold, not too far, and doesn't have much radiation when compared with other planets in our solar system. So those characteristics make Mars a very good candidate for possible life behind Earth. When the Martian exploration started, the first step was really looking at the sky, and we would see that some points in the sky, like we can see in the middle of this picture, we would see a orange dot was different from the stars, and we could see that they moved along the time, but we couldn't have much information about them. Only later, with the telescopes, we were able to understand that it was in fact a planet. Then, with better telescopes, we got better image of those planets. But still quite little comparing with what we knew or what we know today about Earth, for example. It was very hard to understand the difference by looking only with those pictures. The next step was the flyby and the orbiter. They went around the Mars and they could take pictures. That way we had more information about the surface of Mars, but still very, very little. So what did we do next? We did rovers. So rovers really bring a lot of advantages. For example, the Alps here in Switzerland. They are as well very rich in terms of information, but we cannot land there. So what do? We need to land in an airport, for example, and then we need to drive and get to the Alps, right? So the same happens to the rover. They allow us to reach areas that we could not reach otherwise. The first rover was in '97, called Sojourner, and the Mars Pathfinder. So this rover was really a demonstrator of technology. They used very simple maxon motors just to prove that it was possible to drive a rover on Mars and to be driven by Earth, so Earth controlling the rover there. This was successful, and because of that, we had more rovers sent along the years, for example, the Spirit and Opportunity. The current mission on Mars is called Mars 2020. This is because it was launched in 2020, and it's composed by the rover, Perseverance, and the helicopter, Ingenuity. Let's start with Ingenuity. So this is a project that is very dear to me because I was the project manager for the motors that control the swash plates of the rotor, meaning it controls the helicopter going up, down, left, and right. And this helicopter is very much like the Pathfinder that we talked before, the rover, the first rover, because this is the first helicopter that was ever sent to Mars. And because he was successful, because he flew the first time on 19th of April 2021 successfully, and he has done now 33 flights, then we know already that they're going to be sending more helicopters to Mars for other missions. And this is amazing. He opened the skies to new discovery. When we add this aerial component to Mars exploration, we can really go further, faster, explore more, even places where rovers could not go. So this really adds a lot in these explorations. The motors that we developed for this application, we can see them here on the picture, and I also have here one with me so that you can see how tiny it is. So it only has around 2 centimeters length and 1 centimeter diameter, and around 7 grams. And we have 6 of those motors today in the helicopter to control the swash plates. They need to be very light. The lightweight was really the hardest requirement we had on this project. Because if you think about flying, to be able to fly, even here on Earth, you need to create lift. And you create lift by pushing the air down in simplest way. What happened is in Mars, the atmosphere is 100 times thinner than it is here on Earth. So to be able to fly there, you need to rotate the plates much, much faster, and you need to be very, very light. So the whole helicopter is quite light, around 2 kilos. And so the motors itself also needed to be very light. But this worked and it was successful, and we are all very, very happy with it. Now, Perseverance. So Perseverance mission is to collect samples of the Martian soil on Mars. And then we will have follow-up missions to bring those samples back to Earth, but I will come back to that in a second. So here we can see the first sample that Perseverance has collected. We can see the rocket itself, the hole that he made, and then you can see him holding the sample, very happy in the sky. And here you can see the sample inside, that was fast, inside the container. So he already had several samples collected, but this was the picture from the first one. So now how are those samples coming back to Earth? So Perseverance is the first part of a 3-part mission. The second part will be the lander. The lander will be, so the one on the bottom right, they will be sent to Mars. And he will be sent with helicopters on him, so kind of a 2.0 version of the Ingenuity. He will now have small wheels so that he can also roll into the surface, and he will also have a small robotic arm that will allow him to collect samples. And there's 2 ways the samples can get to the lander. The first one is the helicopter will go and fetch the samples that Perseverance will leave on the floor, and bring them back next to the lander. And the second way, and there's 2 ways because of risk mitigation, so in case one of them goes wrong, the second way is Perseverance itself can bring the samples that he still has with him back to the lander. Then the lander itself will have a robotic arm that will take those samples and place them in a container, and this will be shipped to the Mars atmosphere or orbit. And those samples will be around Mars orbit until the 3rd part of the mission. And the 3rd part of the mission is the Earth orbiter that will go from here to Mars, collect those samples from the orbit, and bring them back to Earth. So as you can imagine, this is a very long process, and the technology for the lander or for the orbiter, they are not yet developed. And because of that, it will take at least a decade before the samples that we saw in the pictures before, that Perseverance is collecting today, will reach Earth. So it's really a very long project or program span. So here a little bit about one of the motors that we use inside the Perseverance rover. So you can see on the bottom left our catalog products, the motor and the gearbox. And then on the main picture, you can see how the end result is. And it's quite different from the catalog. But the technology, the core design, it's from our catalog. Then what we do is we make a more robust combination of it so that it can withstand the high vibration, high shock, the several cycles of temperature in Mars, because temperature at night can drop to minus 80 degrees Celsius. And of course, the 6 months vacuum for transport. So all of that requires really robust and reliable motors and gears, because if one fail, and this one in specific is used to collect the sample, so each sample will need this motor, and if the motor breaks or doesn't operate properly, then the whole mission is a failure. So it's really important to have this motors really well designed with very high quality, and of course a lot of testing made on them to be sure that at the end the product is successful. And speaking of testing, here we can see some of the tests that we normally do. So we do 100% test acceptance, which means that all the units that we deliver will be tested. And the tests themselves depend on the customer requirements, but for space, we normally always do vibration, shock, temperature, load. This is the standard for our applications. Now I would like to just finish talking a little bit about the team, the great team with whom I work, that allow this to be possible. As you can see, we have the core team, the space lab, which is the project management and system engineers. And then we have the rest of the team, which belongs to the whole maxon, but on each department, we have at least one person that is, let's say, specialized in space. And those will be our main contacts for design, quality, etc. And you can see here on the picture that women are still in minority. And this is normally true in engineering jobs, unfortunately. But I have seen along the years that it's become more and more common to have women in the teams, and the person that do that really see an improvement on the team performance. And here you can see that, I mean, to increase the variety of the team, you don't just need to increase the gender. You can also use people from different backgrounds, different people from different education places that have worked in different countries. So here you can see all the countries that our team has worked or studied, and we have plenty. And this really helps, because when you have brainstorming sessions or when you just have an issue and you need a solution, if you take a group of people that all studied in the same country, maybe all studied aeronautical engineering, for example, and all on the same university, the solution they're going to give you will be very similar, or at least they tend to be very similar. If you take a group of persons that studied in different countries, they have seen different things, maybe they have different backgrounds, not all the same engineering type, for example, then the solution will be very, very different. And this really allows you to learn so much more and to bring that knowledge into our products. And this is where I work today, in Maxon, Switzerland. It's really in the center of Switzerland. It's beautiful with the mountains and a lake in front. The town itself is called Sachsen, and it's really, really lovely. And before that, I was in Ceia, Matosinhos in Porto, so Portugal. And I worked 5.5 years in Ceia in this great project, the KC390. I started as a designer, and then I had different jobs. And at the end, I was the project manager for this project for the elevator and sponson. And I have learned and grew so much. It was really a great experience, a great team, great project. And this was really the knowledge I have learned here that allowed me to come to Switzerland today. And this is why I would like to share this. And what allowed me to come to Ceia was this brilliant university where I studied aeronautical engineering in Covilhã, Portugal. And the teachers and the lessons we have here, I think they really gave me the base that I needed to be able to start my career, and it was really important. And so much so that I have several friends and colleagues that studied with me in this university, some of them in my year, in my class, that are also here in Switzerland, coincidence, working in other aerospace companies very close to me. And now I'm finalizing my MBA in the Strathclyde Business School in Glasgow. So just to mention that it's not because we take one degree once that we don't need to refresh or to continue studying and continue improving ourselves. So I truly believe that it's important to always try to learn a little bit more every day and to push ourselves. And this is why I would like to share this with you. And this is it on my side. I hope you have enjoyed it, and I'm open to questions if there is any. Thank you.